I print a lot of costume stock. This is maybe about a third of the costumes I've put parts on in the couple years that I've worked at Formlabs, and it's everything from doing the props to closures on it. So, for example, my original designed Venetian, I'm totally forgetting the name I want, doublet, there we go. Venetian doublet in the upper left. All of those buttons are 3D printed, and they are functional buttons, so that's what actually holds my jacket closed. The mask at my hip is also a 3D printed piece. The buttons on my tan wizard coat as well, which I can show you a little bit closer up, as well as the closure, are also 3D printed parts that have been painted with rub and buff and some model making paints to give them a little bit more dimension. So there we go, you can see it better in the light. The belt buckle on my Voltron armor, which is the white armor from Netflix remake of the 80s show Voltron, if anybody's a sci-fi fan, is a 3D printed part with the laser cut inset, so I could make that glow and light up behind like it actually does in the show. The red gems and the buttons on my Emperor attire with the crown are also printed. That full chest piece is a replica of a chest piece, which is very important in one of my favorite shows, Code Geass, and has a very particular set of pieces that they focus in on, in particular the Black King. So that's why I made the full set of chest pieces and put magnets in the bottom so I could actually carry around my board while I was at the event. The blue outfit you see is from a series about people who are gems and rocks. This was actually one of my first original prototypes on 3D printing directly onto fabric, so that's what that collar piece is. Those pieces are embedded resin that is sandwiched through the fabric. And then the armor on my arms and the center chest piece, which is this piece, are 3D printed from the game Kingdom Hearts, if anybody is a Disney or Square Enix fan. So everything from little bits of armor to full large pieces of armor, to closures, to small props, to large props. Pretty much anything I can 3D print, I am very into adding on. So even like the ends of my staff, for example, are printed parts with a little bit of paint, and it's a lot of fun. So you're probably here listening to this talk because you want to learn to do this. You want to learn to make something from nothing, and in order to do that, you need to make a file before you can actually send it to your printer. You can also use 3D modeling for other things like CNCing, which is why I include that GIF on this slide, because learning to model is useful for a number of general construction applications. Going through this presentation, we've pretty much done most of our intro. I will walk you through the pre-build preparation, what you need to consider, and for example in my costumes, how I consider wearability for my parts. We will go into breakdown and how to simplifying shapes, and if you're making something that you need to put on your body, or that needs to work in tandem with a human, say like medical device type things, how to scale that proportionately, at least for a rough first pass. We'll address DFM and DFA, design for manufacturing and design for assembly, so making something that is greater than the sum of its parts. We will talk about the three main types of CAD, the key operations you can do in a parametric CAD program such as Fusion 360. I will do a live demo. I say live because this is something that I've recorded in advance and will be narrating over, considering it was about 2.5 hours worth of modeling condensed into 5 minutes for your viewing pleasure. And we'll wrap it up with just the long story short of, once again, how this is useful for you and your 3D printer. So a couple common definitions for you before we start. CAD, CAD stands for Computer Aided Design, which is basically using a program to help you make a 3D model for an eventual product purpose. CAM is Computer Aided Machining, which takes that model, writes a series of steps very similar to computer code that can tell a machine what movements it needs to actually make in order to do it. And then 3DP, if I use that abbreviation, is just short for 3D printing. There are a bunch of different kinds, such as FDM, fused deposition modeling, that's like the plastic extrusion you see in the GIF going. And of course, if you are familiar with Formlabs, what we do is SLA, where we fire a laser selectively into a vat of resin, it cures, it solidifies those particular parts, it raises out of the resin, lowers back down, and starts a new layer to build up and build your part forward. If you're more interested in understanding how SLA works, I highly recommend you visit our website, formlabs.com. There are a lot of great videos on there about how SLA actually functions, but what you need to do to make your model does not necessarily correlate directly to like what the printer itself on the inside does. We make it easy, so all you need to do is load up your file and press go. To break down, the first thing you need to do is plan out your design. When I approach costuming, I first do this by collecting a lot of references. If you are making something from scratch out of your brain, the way you'll do this is a little bit different, but since I'm trying to do a replica, this is how I approach it. I try to get as many views as humanly possible. If I can get 3D character models, concept art, that sort of thing, it's super helpful. And I also really, really like getting animations of things that I'm trying to recreate in the world if I can help it. For example, if it's from a video game or a show, like the show Rooster Teeth's Ruby, which is this example. The character's name is Pyrrha. getting gifts of that means I can watch how her weapons transform and step through that frame by frame in order to make all of those different parts that shift and move. And I also get an idea from that top left one how her hair and how the fabric on her skirt moves. Although that's less applicable to 3D modeling in general. I really like the concept art piece here, which is why I chose Pyrrha, because I can see all of those little details as well as an overall view of the parts that I need to make. And having that in mind is important, particularly if you're building something large and complicated. You need to have a big overall view of what your final piece is going to look like, but you also need to have smaller defined subsections for all of those little details to make sure that things do fit together properly and encompass all of the geometries that you actually do care about. Here's another example of concept art with the Voltron armor again. I have a number of different views, which is really handy. I can see what parts look like from every single angle. I've got even a makeup detail, which was nice for me, considering I was going to wear this. And getting details that you might not otherwise think of. For example, you look at and see on that concept art, there's like a weird little light thing on the bottom of the shoes, which even if I'd gone through and watched the entire 8 seasons of Voltron again, I probably would have missed. So making sure that you define all of those little details for whatever geometry you're making is really, really important. Otherwise, they'll get missed entirely when you go to actually make your file, especially if you were handing it off to someone else to produce. So this is, for example, is what we use in the industry that is a proper engineering drawing. It generally has multiple views, top, front, side, and an isometric view, which if you're not familiar with isometric is kind of that like angled version of the fastener that we see here. For most of the costuming stuff that I do, this is generally overkill unless I'm sending a part out to be machined elsewhere. But having key dimensions on there, such as how big the holes need to be and how wide, certain subsections of connectors need to be to make sure all my parts fit, is really important. So doing an engineering drawing, if you're doing proper engineering parts, is crucial. If you're doing, say, more artistic parts, this may not be entirely necessary, but you definitely do need to accommodate for the different views, no matter what you're doing. Even if you're looking at, doing a human-style sculpt of a face, what it looks like from the front is very different from what it looks like from the side, and that's going to matter when you do your sculpt. Another thing I need to consider, particularly because I'm designing things that people need to wear and hold and look good with in photos compared to a human body, is scaling. I tend to do things like measuring myself and superimposing that onto artworks before I actually get to doing things. This is also another example, the scythe that I made from a show called Soul Eater. I drew out to scale on a set of gridded paper. So even if you don't necessarily have a lot of fancy CAD work to start, you can start with paper that's just gridded out and you say 1 block is 1 inch or 1 block is a centimeter, whatever scale is appropriate for your project, and doodle it out before you go. I actually made this part before I had any CAD experience, but scaling it out was immensely helpful to make sure that it actually held to the proportions of my own body versus what it looked like in the original media. You can do things like measure your head with clamps if you don't have large enough calipers. I personally like the clear quilting rulers in order to look at the size of my face, which you see in that profile view there, or blowing up things 100% and checking with my hand to make sure that things like glove pieces would fit. Gridding that bad boy out and being able to scale it is really useful for getting a rough estimate of the size things should be, and that can help you kind of put it in perspective. When you're looking at it on a screen, it's very hard to get a sense of how large or small the piece you're actually making is without having just the ruler tell you. So knowing things that the width of my hand is roughly 4 inches, or that the circumference of my head is 24 inches can be really helpful for putting things like these designs in context for me personally. Designing for humans in particular, I generally, like I said, give this at costuming conventions, so I tend to say break things down into simpler shapes. Your wrists and your arms can be broken down into trapezoids, so here to here is a trapezoid that gets wider, whereas if you look at it from this view, my wrist is an oval, the upper part of my arm around the elbow is also an oval. I can basically say ovals, ovals, triangles, combine that into doing my forearm. I also need to consider when doing things like costumes, joints, and movability, which can be important if you're designing something that needs to actually move, bend, flex, or go through mechanical stresses and strains, because if I can't move my shoulder in a suit of armor I designed, I'm really not going to want to wear that for an entire day of a convention. The one thing that is useful no matter what you're doing, whether wearable or not, is thinking about how to break down what you want to make into simple shapes. So, to be fair, it's a pretty simple shape to start. This is the man in the yellow hat from Curious George, if you remember your days of reading childhood books. And how we scaled this was actually made by another Formlabs employee, Zach, so shout out to you, Zach on Materials. And he approached this with a similar way that I approach a lot of my larger, more complicated props. What he did is he measured the red line, number 1 at his shoulders, and then said that in the drawing, that is about the same width as the brim of the man in the yellow hat's hat. So he took his shoulder measurement, made that the diameter of the brim. And then what he said is, comparison to that, overlaid a grid on this image, said, okay, if the red width is, say, 20 inches, then I can use that, scaled grid with squares to say how tall that hat is. Another thing, once you've gotten like that scale sort of set, you can also break it down into simpler shapes in order to actually model this. So what I've got there is a view of the parts that are broken out and also how Zach constructed it. So you've got your disc on the bottom, which is that diameter brim we talked about, and the circumference of my head that defines like what the brim of the hat needs to be so it fits and is also approximately shoulder width. And then you've got a cutoff cone, so a frustrum, that becomes like the main body of the hat, and then kind of like a rounded dome piece on top. And breaking it down into those three pieces made it really easy for Zach to cover this in fabric and then actually wear it. A more complex example that I'm working on is a prop from the game Kingdom Hearts, which we can also break down. Despite that weaponry looking very weird and complicated, we can break that down into simpler shapes too. If we start at the handle, we've got an oval piece with a bar through. This is where she's actually grabbing it. We've got two diamond pieces that seem like they've got holes cut out through them, so I can kind of call them like overlapping squares in a very, very simple term. I personally would approach them like an octahedron type of thing with the top cut off and a hole chunked through it, but that's even more complicated than you necessarily need to do on the first pass. I've got a square rod because I can see that ridge on the top, that's how I know it's not round. And then I've got a smaller square rod with another one that's octahedron pieces in the middle, and then a number of beveled and chamfered cutouts on the piece that's supposed to be like the top of the key. Another useful reference for if you're doing something that needs to be human size is human scale. This is a series of averages made by the US military of soldiers. So you can generally use this as an idea to get a frame of reference of approximately what sizes you need. This won't necessarily work for you or your own individual body, but it's at least a good like sanity check for if you're sizing something that needs to work with a person. If you don't understand what shapes you need, I like to harken back to a like 3D drawing method that is popular in the costuming community, where you wrap yourself in saran wrap and then duct tape. And it sounds very silly, but that blue tape thing you see is a copy of my arm. Then I can draw on the pieces I need, cut them out of paper, put them back on my body, and make sure they work. So if you need to figure out how to make something flat to go to 3D to understand what shapes they are, doing some kind of model like that, whether it's duct tape or saran wrap or tinfoil, can be really useful to you too. So now we'll talk about DFM and DFA, which is design for manufacturing, and design for assembly. So if you're planning your build, you obviously need to start with pieces, but what you should do before you actually start making any one piece is sketch out every feature in 2D before you go into 3D. And this is referred to as master modeling. We actually have a formerling named Adrian, goes by Adrian Tanner, who made the BB-8 that you see on the bottom there. The side view of it's very simple. You just have kind of like the flattened half sphere or so for the head of BB-8, and then the two spheres for the center, so because he made BB-8 hollow. Very simple sketch, but what he did is he also drew out all of the different views of BB-8's top and bottom piece in order to make sure that that piece actually fit, the headpiece actually fit together with the bottom, and then he was able to very easily chunk that out for 3D printing all of the parts. And then you get the super cool BB-8 head that you see here. Another thing to consider when you're building is to use off-the-shelf parts wherever you can. You don't necessarily need to 3D print a plain rod when a wooden dowel or a piece of PVC might do the rest for you, but you can leave the printing for the more complicated parts that would be near impossible to, say, hand sculpt, or that you wouldn't be able to produce cheaply or easily otherwise. One thing, for example, that I use is I made a folding fan for one of my Dungeons & Dragons characters costumes that I've made, and if you look really closely, the fastener that I've got here is a really simple eye bolt. The eye bolt let me put a cord through it so I can put it on my belt. The screw holds it in nice and tight. This solution was $1 as opposed to just like having to make something complicated to hold together all of these laser cut pieces. That's another thing leads me nicely into connections. How are you going to fit your parts together? I've got an example of a sword that was carved out of foam, which I put a core through, so you do need to consider mechanical strength. That's yet another reason you should go check the mechanical properties on our technical data sheets for whatever resin you might be using to print your parts, and use overlaps to hide your seams or screws or whatever connections that you don't need. You can hide permanent connections, make sure that you can access connections that need to be able to come apart and break down. Another thing to consider for printing in particular is leaving room for error. The precision of your printer varies a lot. For using a Form 2 or a Form 3, I tend to leave roughly roughly an eighth of an inch to more than that in terms of millimeters. So 1/8 of a millimeter to 3/8 of a millimeter on all sides of a part to make sure they fit together. I would rather have a part count slightly undersized and slightly oversized because there can be a little bit fractions of microns variability in your printers. So making sure that you can actually get those pieces together and attach them by glue, Bondo, whatever it is you're using to combine them. You need space for that glue, and if you don't leave space for it, you're going to end up with 2 pieces that are oversized and not actually do anything. Another thing to look at is exploded view and assemblies. An assembly, if you're not familiar, is a series of parts that are put together. So you can make a bunch of small parts and then put them together into one part that you can do a nice render out of or an exploded view. So the wand that I've got here on the side from a show called Little Witch Academia, I've got my super nice, shiny, high gloss render that is what I want it to actually look like when I'm done painting this part. But just left of it, you can see an exploded view, which is the top of the wand, the bar that connects it, the top and bottom end caps of the wand, as well as the grip. And you can see on the grip there are 2 little silver parts that aren't visible in the final render. Those are the parts that actually slot together that I will glue down when I finish doing this part, although I will leave personally one end open with a screw such that I can actually get batteries in there and make this thing light up. I've also got a very, very simple example with the gem. There's a gem in the backing. That yellow piece that is painted on the bottom is the backing of the gem that ended up getting mounted on top of a corset piece. Cool. If we don't have any questions from that, like I said, feel free to drop questions in chat if you've got them. We will talk now about computer-aided design, which is, once again, CAD. There are a couple different types of CAD, and which CAD you'll want to use really depends on the application of what your final part will be. They are solid and surface modeling, that is often also referred to as parametric modeling. There is mesh modeling, where you manipulate a mesh in order to get a final shape. There's also virtual clay, and I'll break those down for you right now. Solid modeling, we'll go through a list of programs too as well, or for example, SolidWorks, Onshape, and Rhino 3D. They allow you to define very technical, precise shapes with a lot of dimensions to them that you can actually measure out and mark on your model. They're really good for mechanical models and machine-like props in my case, but for doing machinery in general, this is probably what you want to be using. A couple examples of things I've done in parametric programs are the Sheikah slate from the Legend of Zelda Breath of the Wild game. So that was a part that needed to have electronics components in it, a screen that light up and glowed. So being able to dimension that out and make sure that my LEDs all fit in that was very important for the printing and design process. The Bayard, which is like the weird curvy horseshoe looking thing, is the weapon from, again, the Voltron show to match with that white armor I posted earlier. Just because I say that it's mechanical models and machine-like doesn't necessarily mean it has to be blocky. This is a very round shape, but it's still defined by dimensions and done in a parametric software. It's also really good for things that you need to design that actually need to hold stresses and strains. For example, the buttons on my coat. The black model is the model, and then I inset a series of purple and gold gems into it, hence all of the cavities. But I needed those cavities to fit gems that I already previously had that came as a set size, so I could dimension that out in the model, print it, and know that it would be a perfect size fit every single time. Surface modeling is related to solid modeling. It's on the computer. It's joined surfaces that are practically the same as a solid. So I will kind of use my Girl Scout cookie box here as an example of that. This is a flat piece of cardboard. This is a flat piece of cardboard. This is a flat piece of cardboard. I've got all my tabs that are flat pieces of cardboard. When they join together, I get a single flat surface. The examples I've got here for this one are modeled by Brian Shannon, who was another Formlabs working on our design teams. These are his Iron Man gauntlets and also a pistol from the show Psychopaths. Another example from Brian, who goes by Chose Tech on Instagram if you're interested in his work. He does some really, really amazing builds, particularly in regards to like doing full-on Marvel suits. This is mesh modeling. So you start with a cube. It's just that red cube you see when you open, say, Wings 3D, which is the example that Brian's used here. And then by subdividing that cube and manipulating the edges, the faces, and the vertices, you can eventually pull it out into more complex shapes and then get what is that final Iron Man suit that you see there. Here's another example of mesh modeling. It's, if you're into video games at all, I like to compare this to like the old low poly models of, say, like the old school Final Fantasy type games or Tomb Raider, where things were very blocky and chunky. You don't necessarily get the smoothest model by doing mesh modeling unless you do a lot of refining, but there are options for example, in Wings 3D, where you can auto smooth out all of your creases and sharper lines to get something like that mask on the side, which doesn't even look like it had any true ridges at all, except for that intended crease down the nose. Virtual clay is probably most like the normal sculpting that you're used to. So there's Sculptress and ZBrush are 2 examples. I recommend Sculptress for newbies who want to just play around and give it a shot because you can try that program for free. It is the least precise of the 3D modeling softwares because you don't really define any dimensions to like a measurement, but you can do nice organic shapes as if you are actually working with clay in the world with your hands. It's a good way to think about that is 3D Photoshop. And there are also a lot of hybrid workflows where you'll combine parts like this. So for a combo, this is actually an example of a ring that I did in Fusion 360 that I ended up, the gem in the eye is a resin print, and then I got it printed in metal so I'd have something more long lasting for the jewelry part. It's really nice when you want to do some freeform sculpting. I could do like that very weird mask shape on the top of the ring, but I also had the option to parametrically dimension the actual band that went around my finger because I needed that to fit, else I couldn't wear it. I've got on this slide as well this is a good time to take a screenshot, a series of programs that are useful. So SolidWorks, Fusion 360, Wings 3D, Blender, Rhino, ZBrush, Onshape, Tinkercad, Mesh Mixer, SketchUp, Sculptress, and OpenSCAD, just to name a few. There are a whole bunch of CAD programs out there, and feel free to try whatever you'd like, but this will at least tell you which of them are virtual clay, which of them are solid parametric surface modeling, and which are mesh modeling if you're looking for doing something that is more defined and have a particular project in mind. I'd like to also at this point remind people that CAD is like any other skill, whether you're, say, like me, a seamstress of 12 years, or some other kind of crafter, or a doctor, or a jeweler, or whatever it is that you do. Like any other skill, you will get better and faster with time and practice. Your first model may take you a lot longer than, say, your 10th or 15th model. But if you keep with it, that's how you can continue to grow in your design skills. So now we'll walk through Fusion 360 in particular and go through the basic options of what you can do in a parametric in particular software, because that's what I tend to deal with on the day-to-day, as do a lot of our engineers designing your Form 3s and your printers, and what you can actually manipulate with that. So today we'll be covering Fusion 360 in particular. I tend to use this software as my example when I do the Comic-Con type descriptions because it's a free software for hobbyists. There are commercial licenses you can get if you do want to use this for a business purpose, and it's made by Autodesk, which has some of the most powerful software out there in terms of doing CAD, with a lot of really interesting integrations like physics simulations for additional testing if you want to make a part and then directly put it in a system to make sure it'll do what you want it to do. It's parametric and mesh in one, so if you do want to play with the mesh, you've also got that option with Fusion 360. You've got also direct integration with your 3D printing software, so if you finish a model, you can say, I want to send this right over to Preform, then it'll load up straight into Preform for you. You can generate your supports, press go on your printer, and it's done just like that. This is used by professionals as well, which is another reason I like it. It's good for beginners, it's good for people who are experienced. It's cloud-based, so it runs off of your internet, which means you can also pull files between a number of different computers as long as you have the same login. The forums are also incredibly helpful in terms of having good tutorials for newbies to learn, and people who are also willing to play and help you troubleshoot your model if you don't really know what's going on with it or how you can achieve a certain effect despite your skills. Here is the basic navigation of Fusion 360. This is a slightly older version of the program because I made these slides a while back before they did a graphics update. The layout is still the same, the objects and placements of them are generally still the same, they just kind of updated the icons. So at the top you got your workspace menu, which is pretty much where you do all of your actions from. The upper right is the orientation cube, which helps you change the viewing angle of your parts so you can look at everything from a 360 by dragging that around and clicking on the faces and corners. The browser on the left side of the work area lets you see the views, the planes, the sketches, and the bodies, and I'll walk through what those are as we get to making them in just a couple of slides. There's the data panel on the way far left, which is where you open up all of your projects, your parts, or your assemblies. The view tools are at the bottom, which helps you zoom in and out on your parts and move them around in space. I also highly recommend getting a proper mouse, particularly the scroll wheel for modeling. It's much harder to model on a laptop touchpad, whereas even a cheap mouse from, say, like Amazon or Best Buy or Target will do just fine for you. And then the very bottom of your workspace area is your history bar. This has nothing in it right now, but it'll show you the steps that you've already done once you started modeling, so you can back up if you want to change things earlier on in the assembly and refine larger sections before you refine smaller sections. First thing you got to do when you're, particularly for me, recreating, or if you're trying to work from a hand sketch that you've done into making a 3D model, is making your reference images. The more views you've got, the better, and you can put these views into Fusion by going Insert Canvas. These will make multiple views. You can do multiple views. You can do your top view, your side view, whatever, and line them up nicely based on the intersections of those planes. which is really, really important for making sure that when you're drawing, say, complex surfaces, they all actually line up. An example of making references. Then what you have to do is construct. You need to start making the planes or surfaces on which you can align your other features or sketches. So in order to draw something, you need a piece of paper. And that's what I like to liken the planes in any CAD software to. You need to define a plane or define your sheet of paper on which you can make the sketch or the lines that you're actually going to use to make something 3D. Sketching is where you actually draw out those lines, so you go insert sketch on whatever surface that you've chosen as your drawing plane, and then you can actually draw out the lines. So the sketch you see on screen here is the basic outline of those straps that I showed on screen earlier that I'm losing. So that sketch is what this piece looks like, laid out roughly like this, before I made any of this 3D. Basic operations, now that you've got your sketch, you can actually start making this something solid. So the first thing you can do is extruding. It's like a prism. You start with one face and you extend it straight up into an actual shape. So that part is this top piece here. You can also extrude things at angles, which is how I got these kind of more pyramidal shapes on the bottom part of the Mark of Mastery. So if you say, for example, drag a cylinder out, drag a circle sketch out, you'll get a cylinder. If you drag a square, you'll get a cube or rectangular prism, depending on how high you actually make that piece. There's also revolving, which is taking a shape and revolving around an axis. So something like my water bottle is a really good example of that. I can sketch out this curve right here, revolve it around a center axis, and get something that is perfectly symmetrical. There's also a method called lofting, and I really like the example that Fusion gives you in their hover over. Another nice thing I like about Fusion for beginners is that when you hover over the actions in the menu itself, it'll give you an example of what that looks like. Lofting is where you take a shape and you extrude it up to another shape. So the shape that I've got here is actually just part of the same armor set that this piece was from. It's kind of like a weird swervy bit on the bottom that comes up to a simple disc where a gem gets mounted on the top. So I did this as a loft because I have a complex shape that goes into a much simpler shape, and I want it all to taper nicely. Another option you've got is called sweeping, which is where you draw a curve and then drag a shape along that curve. So that's how I started doing with the spiral part of the side of that piece. I had a circular curve that I dragged along that spiral, and you can get basically a tube that bends and wiggles and does all kinds of meandering. But you can also do this with a square, so you can kind of get like a square pipe as well. Pipe is a good way to think about it. And then for Fusion, we've once again also got mesh. So mesh manipulations, you start with a block. And you start with the block that only has a handful of faces. So you manipulate the faces of this block, you manipulate the vertices of this block, you manipulate the edges of this block in order to shape into something more complicated. As you continue to subdivide, as you manipulate any one point, it becomes more and more defined. So for example, that like big curve you see on the top is something that I manipulated into this cube when it wasn't subdivided a lot, which is how I got a much bigger curve by doing a single pull. Whereas that like single point that is coming out of the front side of this cube is a very, very subdivided part where I pulled in a single point. And since all of the other mesh is defined as being flat until I start manipulating it, it's much easier to do work big and then go down and refine into the tiny details when you're working with mesh in particular. Some other basic operations, corners and edges. The tool called chamfering makes a bevel, and that's pretty much it. You can see it really nicely on that, but it gives me a very nice finish on the edges of the top of this piece. You've also got an option called filleting. Filleting is basically like putting a curve between a 90-degree angle. So if I like to use like the L of my thumb as a good example for this. So when my fingers come together at perpendicular right angle, I do have this part of skin here that makes a nice little curve and smooth things out. Also adds mechanical strength to parts that may just be blocks stacked on top of each other, which can be really useful for printing and also making sure that things fit. Other basic operations, always measure when you're doing things, and once again, for me in particular, because I tend to often deal with things that need to be a human scaled piece, you can use the ruler tool to double check your measurements of any of your parts before you actually go and print something and hopefully don't get the wrong size by doing your checks. So the quote-unquote live demo I'll be doing is from one of my favorite cartoons as a kid, Cardcaptor Sakura, and the magic wand that she uses to fight all of the magical entities that appear in her world. So to show it to you in a still image, so you don't have to watch the GIF, this is her star wand. it's got the star at the top, some cute little wings, a rod that she actually hangs onto, and then like a little gem part on the bottom. Breaking that down, we can first start off by putting this into the simple shape, similar to what we did with the man in the yellow hat and the Keyblade prop beforehand. Working from left to right, so the bottom of the staff towards the top. There's a jewel piece at the bottom that is very similar to, say, like what you get from a lot of our jewelry customers, as well as a setting that fits into. You see the little gold part sticking up off the bottom there. That comes into a beveled ring. Then you've got a bit of a tapered piece that I'll probably do with a loft, and then another tapered beveled ring. Then it comes into the pink part of the rod itself, which is mostly just a straight rod, but it does have a bit of a flare at the bottom. As I move up through like the pink handle grip part, we get to our another gem settings. We've got like a ring there. We have a flat gold piece, which has a red gem on the front and the back, which is why I have 2 red circles on my portion of below. This is another reason it's really important to look at multiple views of this part. You'd only see the 1 red gem looking at the front, but as soon as you turn the rod 90 degrees with the actual prop or look at it in the show, you can see that there are 2 red gems on this part, and I need to know that I have to make both. We move up into the top, which I've only drawn out roughly half of. It's a ring that has a slightly smoothed out edge. I've got a couple of wings that I would sculpt in Fusion, which is another reason I picked Fusion for this project in particular, because I can do all these geometric pieces of the wing, but then sculpt out something really nicely. And then an extruded star in the middle. Cool, so now we will play the demo of the Star Wand. This is at 10 times speed from what I modeled. It was about a 2.5 hour modeling process when I did it from scratch, and I would also like to say this is a fairly messy model because I was trying to do it for speed. I have a couple things that I will talk about, like where I would improve this if I was doing something really, really particular. But to mock up something quick, you can get something relatively fast that might look way more complicated than it actually is. So let's get the screen video going. Cool, so here we are starting out Fusion 360. I am starting out by putting in my reference image, which I am then scaling to be actually my size, and I've spent a lot of time also trying to align it with the origin point that Fusion predefines for you. If you align it with that, then I can do things like make symmetry from the planes, and I only have to draw half of things. For example, I can draw 1 wing and just mirror it over the middle plane. What I'm doing right now is I am making those additional planes, so I'm defining where all of the tops and bottoms of those ring pieces need to be, where the flares start and stop on the handle, how all these pieces actually will fit together. Right now I'm drawing these circles for the ring itself to make sure that it actually matches up with the prop. I'm a little bit off of the exact reference, but I wanted something that was going to look just proportionally nice, so I generally tend to give myself a little bit of creative freedom when I'm drawing that out there. What I'm doing right now is I'm drawing the curves for the star. I actually, in retrospect, this is one of the parts that I would have changed. This is quick and dirty because I wanted to show you how to use the actual like freeform sketch tool with splines. Splines are lines that you can manipulate by pulling on certain points. It's very similar to the pen tool in Photoshop. What I would have done if I can redo this model is I would probably just draw 1 point and then use a symmetric rotation to make sure my 5 points were identical. So that part will look a little bit off in this sketch, but like I said, I wanted to show off how to use splines in the sketch where I really wouldn't get to do much of that otherwise. So I'm back here defining my planes for the bottom of this prop. I'm drawing out my circles for the rod such that I can actually do things like lofts and extrusions to get them to all fit together. And we're just drawing a lot more planes and circles for a bit, so I'll grab a sip of water. More planes, more circles. You spend a lot of time just defining your planes and your circles, defining your planes and your sketches before you ever get to actually making something in 3D. So this is our master modeling stage that I mentioned earlier. Lots more planes as we go. And I think we will soon start actually making things 3D. Here we go. Yes, so this is an example of a loft where I'm doing that tapered part. So that's the bottom of the rod grip itself. Then I just extrude the rest of that tube up because it doesn't need to be anything fancy. It's just a plain cylinder. This is an extrusion of the top of the ring. I've also done a thing where I've mirrored it over the bottom plane because the top and the bottom of the staff are the same. So I've just drawn the first half, drawn the second half in the other direction. And then I am working on the grip portion of, or the top connector grip portion of this. So I'm starting there to make that ring that needs to go out. So you can see how I did that flare by extruding it at an angle. Did another one of those to line up with it. And then I make sure that those pieces have actually connected together so that Fusion will treat it as one solid body. when I go to print it, as opposed to a couple of different pieces that float. Because I will need to refine how those connections fit together, and if Fusion doesn't acknowledge them as one solid part, I won't be able to do that. There's our other beveled ring as it goes. Tweaking that connection to make sure it actually fits right. Another thing I will mention is that if I was actually designing this prop, I would probably make it collapse. So this is a part that is modeled entirely in one solid piece. I would probably split this into a couple different pieces. So I'd probably make that end cap, that like little gem part that we're working on right now, one piece. I'd make the rod grip another piece, and I'd make the top of the staff different and have them say either just fit together with a press fit, or just a fit that I could, maybe not a press fit because I'd want to be able to disassemble it, or some kind of screw point at that section, so that I can disassemble it and put it in my suitcase and take it with me to whatever event I'm going to. But this prop is also fairly small, so I could just do it in one piece. What you'll need to do is break up your parts, if you're doing particularly large parts, to fit inside your printer. If you're doing small stuff, it doesn't really apply to you. But knowing how to break things up to actually fit them in your printer is important. Like I said, this is where you do your sectioning off and do your tolerancing, such as what I mentioned earlier in the DFM and DFA portions of the slide. This is an example of the revolve. I drew kind of just like a curvy part on quarter of a circle, roughly quarter of an oval more like, and then revolved it around to get that. That is our extrusion of the star. Like I said, it's not quite as neat as I would have liked, because I would have liked to do that with a symmetrical sketch as opposed to just like the quick and dirty curvy bit that I did here. That's one part I would refine if I was going back and doing this for real. And then I'm using the fillet tool here to smooth out a lot of those edges so they're not sharp and harsh. I want this to be rounded because Sakura is cute and a lot of her props are not very like sharp or harsh or rigid, so I wanted to make this a smoother, cuter part. That is another example of the revolve where I did like the little red gem piece. That's a 180 revolve of a half circle, so it's just from here to here. Then I have to make that connection to make sure it actually connects up to the big ring itself. That's what I'm doing right now. There we go. Now we start off on the wings. So I brought my reference image back, and then we are going to start working in a mesh for particulars. So this is the spline tool once again, where I'm drawing out the outline of those wings. Then I make an extrusion with the spline. You see I've got that overlap there. That's a problem, so I have to go back in and adjust it. Meshes are not happy generally when you've got lines that intersect each other. So I've now made my wing border, which I fill in and start manipulating to get something that I'm happier with. What I wasn't a huge fan of is how like that weird cut was happening because of the way that the corner was aligning on the mesh. So what I ended up doing, and you'll see that here in a second, is I split up the wings into 3 different sections. So like the tiny little bump, the middle bump, and the large bump, and then combined them such that the combination points weren't giving me bizarre, weird curves. Yeah, so here you can see me, I've broken it into 3, and then I would just merge them. So such that those connections can be a little bit sharper and cleaner. That's where I start filling it in. I'm working with that middle piece. Then I'm working with that end piece. Then I'm working with the bigger one. Cool. I then proceeded to mirror that across to the other side. Once I had the top-bottom symmetry solved, then I mirrored it left-right. Yeah. And that pretty much gets us to the end of the video and what we have as our final prop. So if you take anything away from this, what I would recommend is remember the following. 1, when you're approaching making something complicated, you need to break it down to simpler pieces and shapes. What shapes are define like the main body, and then all of your smaller features as you work out. What shapes are your holes? What size are your holes? Thinking about those types of things coming in, and even drawing dimensions, particularly if you need it to be something that's not as freeform, can help you think about it and make something that will work for you. If you are making something that needs to fit with humans or other parts, use your reference images, use those other parts, use your body to give yourself an idea of how that part will actually be scaled, and then come out of your printer at the appropriate size. Remember also too that your parts aren't perfect no matter how good your printer is, so you need a tolerance, even if it's something like fractions of a millimeter, to make sure you can accommodate for whatever assembly method you're using, if it's glue, Bondo, whatever it is you're using to combine the pieces. You also need to remember to use the right type of CAD for the job. If you're doing something more freeform or organic, a mesh model or a virtual clay might be the way for you to go, but if you need something that has to be very defined and dimensional, that's where parametric is going to be way more useful to you. And most importantly, CAD's fun. Have fun with it. If you want more from us, once again, I'm Cassie. I go by Stars of Cassiopeia online if you're interested in more of my costuming work in particular. I also sometimes do live CAD streams on Twitch if you want to see what this looks like when it's done in real time. And I'm happy to answer any questions that you've got. Feel free to reach out to me. I also want to plug Formlabs sessions, so thank you Formlabs for letting me on today and letting me share like what I do outside of work, my craft, and introduce people to CAD in general. If you want more content like this or other things like Formlabs' response to COVID-19 and how 3D printing can be useful for a medical crisis, or what you can do with your 3D printer at home now that you've moved your business over to working remotely, check out our full lineup of these during lunch, afternoon, introductory sessions or educational streams at formlabs.com/formlabs-sessions, which has also been linked in the chat. So check that link for on-demand content that you can watch right now, as well as our upcoming stream times. And I want to say thank you again to my moderators in the chat, as well as Formlabs itself for giving me the opportunity to talk with you, and I hope that you enjoy the rest of your Tuesday afternoon. Happy crafting. I always say happy crafting when I sign off for my costuming live stream, so happy CADing!